This question is regarding the oxidation of alcohols. We are given two diagrams here. One is a typical distillation setup, the other is a reflux setup. And in the question we are told about a particular alcohol being oxidized to either ethanol or ethanoic acid. We are also given the boiling points of three compounds: ethanol, which is a beginning material, the reagent, as well as one of the possible products, ethanal, which is 21 degrees, and ethanoic acid, which is 118. Just a quick reminder that ethanol has hydrogen bonding, therefore a relatively high boiling point. Ethanal has no hydrogen bonding, therefore a low boiling point, and ethanoic acid has the most hydrogen bonding, and therefore it has the highest boiling point of 118 degrees centigrade. In attempting to answer this question, we'll have to make use of both the information regarding the boiling points given to us in the table, as well as the type of equipment being used in each case. Before attempting to answer the question, I'd like to take you through a quick video reminding you about what the process of boiling involves in terms of two liquids which have unsimilar boiling points. What we have here is a little video about two different compounds. The volatile component is shown in blue, the non-volatile component being described by the red molecules over here. Now when we actually do start to heat this mixture up, what you will notice is that the blue circles will tend to boil over first, and the red ones will not boil over, as you can see over here. The red molecules not boiling over, where the blue ones being released and being collected through the condenser over here. Now let's apply this situation to a specific case of oxidizing an alcohol to an aldehyde. Now what you'll notice here is that we have the oxidizing mixture over here, and the yellow aldehyde is being oxidized across without the formation of the carboxylic acid. And the reason why that cannot happen is that the oxidizing mixture is present over here. Once the aldehyde is distilled off, there is no way the aldehyde can come back and react with the dichromate inside the reaction flask. And hence you have the answer here that the volatile components can easily distill out, and of the volatile components, ethanal is indeed the most volatile because it's got a lower boiling point and only partial oxidation has been achieved. In the second part of this question, we're asked about apparatus 2, which is reflux. And again, I have a short video here to describe the process of reflux. And what you will see in this video is molecules which are being heated up in this view over here. They are rising up, but as soon as they hit the cold surface of the condenser, they will drip back down again. Now what that means in terms of the oxidation mixture is that the aldehyde being formed here will rise up, cool back down again, react with the dichromate to form the carboxylic acid. Part B is a very straightforward equation requiring you to state the oxidation of an alcohol. Just do keep in mind that in this particular case, when they're asking for the oxidation of the alcohol, they're asking you to go through the aldehyde route. So it will be CH3 CHO, the alcohol being oxidized to this first, and then following that it will be oxidized to the carboxylic acid. The reason why you've got two oxygens here, one oxidation equivalent is used to oxidize to the aldehyde, and the second oxidation equivalent is then used to oxidize the aldehyde to the carboxylic acid. Note there's only one molecule of water being formed, and the reason for that is when you oxidize the ethanol to ethanal, you release one molecule of water. However, when you oxidize an ethanal to ethanoic acid, no water is released. Part C of this question is a standard infrared spectroscopy question. What you have over here are three spectrums given to you, A, B and C, and we're asked to justify as to which one we would think is ethanal. And keep in mind, ethanal has the functional group of C double bond O H, and this particular functional group has a typical absorption within this region over here around about 1700. Now, as we can see, all three spectrum have this particular peak. However, spectrum A and B also have a peak of a hydroxide or OH, which could be either due to a carboxylic acid or an alcohol, and ethanal clearly does not have any of these peaks, so the correct answer is C, as it has the absence of any OH absorption in this area here. And that's exactly what we have in the answer given to us in the mark scheme, that the answer should be spectrum C, because it has an absorption around 1700 for the C double bond O, and the fact that the two other spectra have an OH group around about 3000, which the aldehyde will not have. In this final question, we're giving a typical mass spectrum as well as an infrared spectrum, and the scenario of the question is an alcohol again. Again, it's been oxidized by acidified potassium dichromate, and we're asked which of these given alcohols is our starting point. First thing to notice is the molecular ion peak, and let me remind you about the molecular ion peak. This is the peak which is the furthermost to the right, or you could say it's the peak which has the highest mass to charge ratio, which is 60 over here. So that gives us some indication about what the alcohol is. Another vital piece of information given to us is this information over here regarding this peak over here at 45. Now what this is telling you is that if you have a peak at 45, this could have only come from this fragment over here, and that particular fragment is only present inside propan 2O. Once we become familiar with the information that the starting point must have been propan 2O, we can clearly see that the infrared spectrum of F, which is the oxidized product, must be propanone. And again, we have confirmation for that. Why? We have the peak around about 1700, which is a carbon double bond oxygen peak, and we have an absence of any OH peak, which means that the alcohol here could not have been oxidized to a carboxylic acid, and therefore this particular spectrum must be that of propan 2O.